So this is a short video, hopefully, on how we can use QGIS in analyzing the driverless data and crowdsourcing data. And this is a special case where I don't have the site database of the network in question. So there are some specific data analysis tasks for which QGIS can be very handy. So over here I have a sample database. This is a driverless data, not crowdsourced, but if it was crowdsourced, you would expect much lower number of gaps. There are 6,000 samples here, and what I'm going to do is I'm going to try to estimate the locations of the LTE eNode B from this data, and I will also try to estimate the Voronoi for each eNode B, so you can expect that this is the coverage area of the sites. Of course, it can be extended, and after getting this information, you can try to see what is the average site-to-site distance for an operator in the area. You can benchmark it versus your own network and so on. Again, I will try to be quick, so if some section is quick, you can, is too fast, so you can just pause the video. So the first things first, there is something which is called the mean coordinates. The input data is a drive test. The weightage should be something which we can utilize. So in case of LTE, we know that RSRP, higher RSRP means we are closer to the site. And when I say site, we only know the eNode B ID from the driverless data or the crowdsourcing data. The problem is RSRP is negative and QGIS cannot apply negative weights. So we need to fix this. So what I'm going to do is, this is sort of a hacky method where I will try to create a new field which is called ASU. It's the same ASU which is defined in 3GPP. And I will just do this. If RSRP is lower than -140, then it is 0. Else, if it is greater than -44, then it is 97. Else, so this is what I get, and I think now this will be a positive number between 0 to 97, representing the signal strength. So you can come here again, the mean coordinates, sample driverless data, weight field is our ASU field, this unique cell ID is the eNode B ID. We will run it, close it. These are the expected site locations, just to see. So it's 500 meters, 800, 600. This is good. This one is not so good, so it means most probably it's a small cell deployment. So there are two eNode B IDs, but maybe they are sharing the same physical structure. Anyway, so this is how we get the approximate site IDs, site locations. We can also use labels to see the names. eNode B apply. Okay, so for example, these are the eNode B names. Then the next thing what we can do is we can even estimate the distance. So the source, the destination is the mean coordinates. The hub layer, that of course we want to group everything on site IDs, and this is the unit of distance, so I will just use feet. Okay, closing it, this is it. So what this is showing me potentially is the distance of each sample from its expected location. So if you were trying to detect overshooters, you can do it. So maybe these are the samples of your interest, so maybe you consider this as overshooting or not, but this is how it can give you an idea. And the last thing, as I mentioned earlier, was the Voronoi. So you can go here, Voronoi. You still need the mean coordinates because this is the layer where you are expecting your sites. So this is the expected area now, and you can color it, categorized by maybe apply, and maybe some sort of labeling. Okay, maybe apply, and maybe, sorry, again, I think we should do layer rendering, maybe make it a bit transparent. Remove the hub distances. You can come back here, trying to make sense. So symbology can be categorized, and what I'm trying to do here is I'm trying to see how well the Voronoi capture the site differences, for example. So as you can see, this is a single Voronoi, and the sample coloring inside is mostly one color, so it seems a good approximation. Then again, this purple coloring is mostly here, and Verona is also trying to say that this is my coverage area. So this is how you can estimate the coverage area of even a competitor for which you don't have the site ID information readily at hand. Thank you.